All right, thanks for coming, everybody. I know there's a lot more exciting things you could be doing right now, so I really appreciate you being here. There's crazy parallel stuff going on this year at Dreamforce. So my session's called Blaze a Trail to Predictive Selling with Einstein Intent. It's a developer session, but it's got a little bit of a business value twist to it, so hopefully you guys appreciate that. My name is Daniel Peter. I'm a two-time Salesforce MVP. Lead applications engineer at Canandy. That's a cloud ERP built on Salesforce. I got 22 Salesforce certifications, and I've got my social media, email info up there. I'm pretty active on Twitter. I'd love it if you guys reach out to me or include me on any posts or questions, anything like that that you have. So how many folks are familiar with the Einstein Intent API? If you guys read about it, done the Trailhead module, or worked with it? Okay, I'll just talk a little bit about it then. It's a natural language processing classifier, but it's provided as a service through Salesforce Einstein. They market this for lead routing, case routing, things like that. But actually looking at it, it looks like you can use it as a general purpose classifier for any natural language classifications problems that you might have. So I was very curious when it came out, could you use it for other things besides lead routing and case routing? It turns out you can. I actually did this, this little proof of concept. So what we have here is a couple of curl requests and responses. I went online and I found some market basket data, people that bought like goods in the same market basket. And you can see an example of one of these was like ribs, beer, pork, candy, milk. And this classifier actually recommended, 98% that you buy pretzels. And this other example, you bought fruit, yogurt, candy, and this thing, 70% recommended chocolate. So I was like, wow, this thing actually does have some potential here. You could use it for other things besides lead routing and case routing. So I got pretty excited about this, and I posted something on Twitter, and the chief data scientist at Salesforce, Richard Socher, he retweeted it. So I was like, wow, I got even more excited about it. And then Mark Benioff, the CEO of Salesforce, retweeted it. So I was like, okay, this is cool. I'm going to submit this for Dreamforce. So I did, and I got accepted. But I didn't want to just use that market basket sample data that I found online. So since Canandy's a cloud ERP, we have a lot of manufacturing type customers. And I asked around at the office to see, do we have any customers we could work with to try to use this Einstein Intent AI on their actual data? So it turned out one of our customers, TentCraft, was a good fit for this. So TentCraft uses Salesforce CPQ and Canandy Cloud ERP. And they're a very cool company. They make these custom pop-up tents, inflatable tents. They make all kinds of accessories that you can join these things together like Legos. You can, add walls and tables, heating and lighting, basically infinite combinations of different ways to sort of set up, your awnings, your shade, different things for your event. So they agreed to let us use their real data for this proof of concept. So it's very cool. So the first thing I did was I kind of looked at their tent, their product line, to try to make a good use case for what we could do. So they make these tent products that are kind of like a core product. They're like big types of different tents, octagon, whatever this one is, pop up, these different styles. And then they also make these things that are more like add-ons for those core tents. So it's this is like a LED lighting kit looking up to the top of the tent, these flags on top, heating, these roller bags for carrying them. So what I was thinking was, let's try this as a use case. Let's try to do the classic recommendation scenario. So maybe you bought a master tent, and we want to recommend to you should consider buying these weighted foot plates. Pretty much everybody's familiar with this recommendation. Amazon's been doing it forever. It's kind of the classic use case. But so how do we go about doing this? This is kind of a high-level overview of the process of how this machine learning works. So what we do is we take this training data, it's here on the left, and this can be classified as independent and dependent variables. The independent are things in this case like tents and sidewalls, which are more like a core product. The dependent are things like lighting or a flag that are more, the add-on product. We take all that training data and we feed it into a model. Once we have this model built, later on we can come back with a new set of independent variables and feed them into the model, and this will predict a dependent variable coming out. So we can basically use this to take historical data, run some algorithms on it, and attempt to predict the future. Pretty cool. So in terms of the data that we need to feed this, we have sort of two categories of data. We have what Einstein calls examples and labels. These are like the dependent, independent variables. So the examples on the left, you can see these look like product names, master tent, transit bag, things like that. So what I've done is I've taken a Salesforce CPQ quote and taken the products on that quote and sort of made a little sentence or paragraph out of those products. The natural language processing uses that to predict what label it falls under, which is here on the right. And these are sort of like add-on products. That's just a small subset of kind of what the data we're feeding this thing would look like. But to create that data that we just saw, it's actually not coming right out of Salesforce. We have to do a transformation step. This data prep is super important because basically I can make or break your model. So in this case, some of the things I had to do, as I mentioned, I separated the items into core and add-ons. I had to find some way to group them together, kind of in a basket, to build that sentence or paragraph. So I used the quote itself. So these are lines on the quote. And then, I'm able to feed that in as the independent variable. But, there is this clean data step. I was talking with the CTO at TentCraft, and he mentioned some customers that he just knew off the top of his head were outliers. So certain customers just order this like specialized thing all the time. So he said you might want to exclude them. He also said, I also learned that there was a lot of duplicate data, and there's an issue with duplicate data. If you feed it into Einstein, it only counts the first one. So all those duplicates drop out, which can actually leave you with not enough data to build a model. So you want to do something about those up front. You don't want Einstein to give you an error later because you don't have enough data because you had so many duplicates. So that's sort of the data, the model, and how we're going to build that. But once we have that model, we need like a UI to get some business value out of it. So what we see here is the Salesforce CPQ quote line editor. And this is a quote that, just an example quote that I built. And we've added this predict button here. And that's what the user is going to push to be able to do a prediction on our model. And when they push that predict button, they'll see this overlay UI. This is a Visualforce page. You have a drop down here to choose your model, and another drop down here that helps you refine the model if it gives you a bad prediction. And you can pick products that are recommended and add them to the quote. And we'll use this live later. But to get that button to show up, we had to configure a custom action in Salesforce CPQ. So this is very cool. You can customize the quote line editor very extensively through declarative means. In this case, what we've done is we've added a button action right here, and the URL target is a pop-up. The pop-up is a Visualforce page, and you can pass the ID in as a merge field. You can put any fields in here that you want. Very cool. And then this is just saying we want to see it on the quote line editor screen at the top of the quote. So that's all we had to do to get that button to show up. The architecture of how this was built maybe is not exactly what you want to use in production. This was a proof of concept, but I'll go over why I did this. So I've got two flows here. This is more the training flow. So this is like taking the big data dumps out of Salesforce, crunching it with the data preparation, and then putting that into Einstein, training the model. So for this, I actually use laptop. Believe it or not, your laptop is like more powerful than a lot of servers on the cloud. 16 gigs of RAM and all this. So this can actually crunch like hours or days worth of batch Apex in like seconds. That's why I use that. Also, data storage costs are cheap. So instead of loading years of historical data into this Salesforce CPQ dev org, I just left them in CSVs on the laptop. So the flow for predicting is a little different. I'm using a Heroku proxy. You can actually call the Einstein API directly from Salesforce CPQ or from Salesforce in general, from Apex. That works great. There's a couple libraries out there where you can pull the Apex to do the HTTP requests in the right format for the Einstein API. I started that way. It worked pretty good, but actually ran out of gas. So what I was hitting, I think maybe heap or CPU timeout because Tentcraft had years of data. So I moved to client side because client side callouts, they don't time out. There's no governor limits there. But because of the cross-origin policies, I couldn't call directly client side. I had to go through a Heroku proxy. So once I had the Heroku proxy, I took it a step further and I did some more optimization. And I did some things like, if you guys have worked with the Intent API in Apex, it's very difficult to build these multi-part form requests. It's this crazy IEEE standard or something where you have to post in the boundary, you have to do binary encoding and get a byte length, and if it's even one little piece of it is off, your request will fail. That's much easier to do with Node.js libraries, so I took advantage of that. So I'm doing the multi-part form building on the proxy. So Salesforce makes a very simple request to Einstein. Heroku handles the difficult stuff. And the other thing I did was I made my own sort of Einstein API method called Dataset Details. So the Einstein APIs are very granular, and in order to get like all the data sets with all the model details, it was approximately 4 API calls per data set or per model. So instead now it makes one call, and Heroku does all this stuff in parallel between Einstein and then returns one response. So it's also better performance because you have cloud to cloud when you're doing a ton of API requests, and then this may be on a poor Wi-Fi connection. So you get the good big pipe when you're doing all the requests, and then you distill it down and give one response. So a little more efficient. So that's how it's working on the back end. So how about this idea of using natural language processing for product recommendations? I mean, does this sound kind of strange to anybody? I know if you work with machine learning in the past, you're probably used to using things like primary foreign key relationships. It's like, why would you want to use sentences and paragraphs? So I agree it is a little strange, but I did want to try it. And again, the data prep makes or breaks this because it's looking at the words. So you don't want to feed it things like Salesforce IDs and a lot of numbers. But the cool thing about it is it's sort of fuzzier than using that primary key logic. So you can actually predict products that aren't in your catalog if there's some similar words for products that are in your catalog. So that part's pretty cool. And the other thing is you can kind of add in this unstructured data. So you might have your transaction might have some related records a couple lookups away, things like customer demographics or what season it is. You can throw those in also. So it gives you a lot of flexibility in terms of things beyond the transaction that you can throw at this. All right, so I'm going to jump into a code demo now. It's kind of have two big parts. One is that first flow that we saw where we're using the laptop to generate the file with the Salesforce data, post it into Einstein. The second one is we're going to actually go into the quote line editor and use this thing to try to do a prediction for an upsell. So you can see I've been using this quite a bit. There's a lot of output here. I've got just a little Node.js script that I built. And what it does is it takes the quote line raw data, this 150 megabyte file, and dedupes it, pulls out outliers, does a bunch of things like that, and produces the right JSON format for the Intent API. I won't go into too many details on this unless you guys have specific questions later, but this is just a quick look at this script. It's using a library that parses the CSV, so it's pretty easy. Basic ETL script, CSV in, dedupe transformation, JSON out. So I pull open this file because it takes to open. But I will show you the output when we're done. So if we just run, can you guys see that okay? If we just run, let's call it Dreamforce. See, it's fairly fast. This would probably be hours long Apex batch job. We're just smoking my laptop here instead. All right, there's our file. So we can take a look at this. And that's a little hard to read. I've actually got it open already here. So here's what it looks like. We've got this object. It's got one property called intents. And every child property of intents is a label. And a label represents one of Tentcraft's add-on products. So here's like their 10 by 10 Mighty Tent roller bag with 30 examples underneath it. So each one of these examples is like it's a cleaned up version of the quote lines on a quote. So that's the data we're going to use to train the model. What you have to do to train a model, or actually to upload a data set and then train a data set, is you have to take all this JSON, or you can have it in CSV format, and do that multi-part form post. I've actually built a little tool to help me with this. There's a couple of them floating around out there. Einstein, some other things. I built one because I wanted it to be special purpose for my presentation. So here's what mine looks like. I'll tell you what these are in a second, but for now what I'm going to do is I'm going to take that data set, paste it into this window, and upload it. And what this is doing is going to the Heroku proxy, doing the multi-part form request, sending it to Einstein. And you can see I've already done this with a bunch of them. I've been playing with this thing for a while. So these all represent data sets that I've uploaded into Einstein. And over here, models underneath data sets. So in this case, we have one model. Some of these we have more. This is how many examples are in the data set, and this is how many labels. So the one we just uploaded, let me refresh. The one we just uploaded has 20 labels and 607 examples. So, these are the labels and these are all the samples. It's done that for us. It's summarized that across the whole thing. So once you have a model, once you have a data set, you can create a model from it. It does take a little while, so I'm not going to make you wait. But here's one that I did earlier. So this one's sitting here in a status of queued creating. This one has a status of succeeded. And just a little bit about the models. I'll go into this more later, but I just want to show you a quick overview. So this model here has an overall accuracy, a test accuracy of 56%. Not the greatest, but a little better than flipping a coin. It went through 100, or it said it was going to go through 1,000 epochs, but it actually only went through 60. It did an early stop. This is because Einstein was going through iterations and found out that it wasn't getting any better, so it stopped. We also have details on every single label in here. So the 6-foot table cover has an F1 score of 23%, so it's not a very strong label, but the one underneath it, the 10 by 10 Mighty Tent transit bag, is pretty good, 83%. We also have this confusion matrix, which I will go into in more detail later, but this is an even more detailed version of what makes up a good predictor for the label or not. So that's this is just a little back end. This isn't what you would use in production, but this is great for a proof of concept. It lets you build data sets, models. It lets you see what's going into them, delete them. I built a little thing to predict against them right here. So the way I built this was I did an Einstein app, which is right here, einstein.app. This contains a component. It's got a ton of Lightning design, HTML mixed with basic components to build this fairly complex UI, with the accordions, the buttons, all the data grids. So this is all the markup, and then as far as the client side callouts that are calling the Heroku proxy, I'm just using good old jQuery to call my Heroku proxy, and this is a syntax for calling a proxy. You call your proxy and you just concatenate what you want to be on the other end of the proxy. So we're calling Heroku, but it's calling Einstein right here. So that's a little bit on the code of how this thing's built on the back end. I have some more stuff I can show you. I'm going to make this interactive when I get further down, but I just want to give you the lay of the land here. So in terms of using this model, once it's built, what we have right now is, we're in the Salesforce CPQ, Lightning app. They have their own quote custom object. We can open an existing quote or we can build a new one. I'll start by opening an existing one. This is just standard Salesforce detail screen here. Once you go down here and click on Edit Lines, this brings you into the Salesforce CPQ package. So this is what we were looking at earlier in the slide deck. This is a custom screen with the custom predict button we've added. So here's a quote. We've added some things: a 13-foot counter, 10 by 10 master tent frame, some connecting clamps. I just added these randomly. And we can click the predict button. We can choose our model. I saved a few. The idea is here you can make different models for different purposes. If you have a certain promotion, where you want to push products or something like that, you can create a model that just contains the labels for those add-on products as part of your ETL. You're not limited to one model. That's what's pretty cool. And you get predictions. And what this did is it took all the products on the screen behind us, fed them into Einstein, and then Einstein recommended these upsells. You can see they have pretty low percentage matches in this case. If I use data that made more sense, we can try that later. It might produce better matches. But what it's told us, I think this says 13-foot counter. I think we might have had a different counter. Maybe we had the same one. So the idea here is it's an assistant, but the rep can actually look at these, and if they don't like any of these, they don't click them. They won't hit add items to quote. But if they say, actually, for this bundle of goods that I chose, this would have been a better option. A wheel set would have been better. And what you can see is if they do that, if we come back here and look, we've got the model we happen to be using is the second one from the bottom. I happen to know that. So I'm going to collapse this so it's a little easier to read. We've got 609 examples. So the idea is if a rep wants to say, hey, this is actually a better fit, and then revise the prediction model, it's going to feed this back into Einstein. And this 609, if we refresh, should go up to 610. Yeah, so there we go, 610. So it's making the model smarter. So I'm not an expert, I'm not a sales rep for Einstein or for Tentcraft, so I'm not the best person to retrain this model or even pick products that make sense together. Actually, I look forward to circling back with the customer and doing some real-world scenarios with this. They can put, a realistic quote that somebody might order and say if the recommendations are good or not, that kind of thing. I think actually what I want to show you quickly, even though this is only 26% match, let's go ahead and add it anyway. So we can see we had one here. Now we have another one. So for some reason it thought that we had a 26% chance of selling them another 13-foot counter. May or may not be a good recommendation, but that's where the human element can come in. So that's a quick demo of kind of how you can use this. Actually, I will show you one more thing. What we just saw, that overlay window, is actually a Visualforce page. Have you guys worked with this Lightning Style Sheets True yet in Visualforce? So it's using that, so that's kind of what you can expect it to look like. This is pretty light. This isn't formally Lightning Design. This is Steelbrick. Now Salesforce CPQ built this like pre-Lightning Design, but it looks just like Lightning Design. And this matches pretty well with it. So it's not an exact match, but it's mostly kind of a light color scheme. And if you were to flip this org back into Classic, this would actually look like an old Visualforce page too. So that's one of the cool things about using this Lightning Style Sheets True. And this form's pretty basic, It's got the buttons on top. It's got a page block table, all the classic Visualforce stuff that we learned to love over the years. And then it's got a controller behind it that's calling that same Heroku proxy to make the predictions, and then also to do our revisions if we think we can improve the model. Okay, so I want to talk a little bit more about the accuracy. This is very important. What good is machine learning if it's giving you garbage results? So it's very important to learn how to interpret all these accuracy metrics so you can use them to improve your model. So there was 3 up until a week or so ago, and now there's 4 ways to interpret the accuracy of your model. And these are organized from least granular to most granular. So at the top, we have an overall score for the entire model. And there's actually 2 different scores. There's a test and training accuracy, and this is like 0 to 1, basically 0% to 100%. Really just focus on the testing accuracy, because what Einstein does and what most machine learning does is it partitions off like 25% of your data. It doesn't use it to train the model. It feeds it back into the model, and it actually knows what the results should be. So it can tell you if you got it right or not. So the testing, if you have a good testing score, you have a really accurate model because it actually knew what the results were supposed to be. So really just focus on the testing score there. The F1 score is also kind of a 0 to 1 or 0 to 100%. The F1 score is at the label level rather than the model label. So you can tell, you're really good at upselling, in Tentcraft's case, maybe you're really good at upselling like a flag or a banner, but maybe other things, the prediction is not so strong, closer to 0. And then this confusion matrix we saw briefly. I have another slide on this, but this is even more granular. So this tells you kind of like why your F1 scores are bad. And they just came out with this learning curve. Have you guys seen this yet? So the learning curve is the confusion matrix. It's basically all this stuff, but over time as it's training the model. So we saw those epics, it could do up to 1,000 iterations. It stopped at 60. So you'll see like 60 samples of how this improved over time. So this gets into interesting stuff for like performance tuning your models. So you might see this learning curve actually drops off steeply towards the beginning, and you might want to not go through that many epochs. And I actually have a visualization on that we can take a look at too. So the first two are kind of pretty intuitive. They're just like a 0 to 100% score. The second two are a little more complicated, so I'm going to like demonstrate those so you'll understand. All right, so here's the confusion matrix. Has anybody seen one of these before? This is like classic machine learning classification stuff. So on the rows dimension, we've got what the prediction is. On the columns dimension, we've got what the actual is. So in this example, we're predicting, is it a cat, a dog, or a rabbit? So, if you go down the rows, we can say, we predicted a cat when it was actually a cat 5 times. We predicted a cat when it was actually a dog 2 times. We predicted a cat when it was actually a rabbit 0 times. So predicting this cat was quite a bit better, than predicting a dog. So it's, fairly accurate. Right here, we had a predicted, we predicted it was a dog when it was actually a cat 3 out of 3 times. That's not very good. We predicted it, basically, we can't tell if this is a dog or a cat is what this is telling us. But we can almost tell if it's a rabbit, right? Like it's a little bit lower. But now we come down to the rabbit and we see, we predicted this thing was a rabbit when it was actually a cat 0 times, 1 time. So we're pretty good at being able to tell if it's not a cat or a dog, and we can definitely tell when it's a rabbit. So the idea is here, you want to look at this diagonal and you want very high numbers relative to outside the diagonal. So you want to have your actual and predicted very high and your sort of misclassifications very low. And what you can do is you can kind of diagnose your model with this. You can easily tell, this 11, we're very good at predicting rabbits. We're not so good at predicting cats and dogs, so we need to throw some more stuff in our model to like tell the cats and dogs apart, that kind of thing. And we actually get this confusion matrix with the Einstein API. So that's what we were looking at. And so in this case, it's a lot more complicated than cats, dogs, and rabbits. We've got many products by many products. And we don't have the labels across for what they are and if they're actual or predicted, but the data is laid out in the same way. Think of this whole thing as the big confusion matrix there. So you can kind of, look down the diagonals and see where it's good, where it's bad. There's that F1 score, 0 to 1. And then we have the test and training accuracy. Actually, that's up here. 56, 75. So the new thing that's very cool that I was talking about is the learning curve. Is this one's still running? Let me refresh again. Maybe it's done. We might be able to check out our brand new model we just created. Success. Okay. So I created this button actually right before this presentation because this API is so new. And this shows the learning curve of all the epochs. And this is showing, there's many data points that we could use. If we look when we call that API, learning curve, for every epoch that it did, we get all the data points. So I'm just pulling out the most important one overall for the model, which is the test accuracy. But you can even pull out the confusion matrix for every epoch. And I don't know how you would visualize a confusion matrix over time. That's a lot to look at. But in this simple example, we see, we can actually see the accuracy of the model going up as it's running its iterations. And then we can see it kind of goes down and up a little bit, so it decided to stop right there. But you could do some really interesting model tuning with this. All right, so I just wanted to point this out. Einstein Intent and a lot of the Einstein platform services are still in beta, and they're working on them fairly frequently. So here's the release notes. I took a look at these today, and on October 27th, they just released the new learning curve metrics. So key is here, just keep an eye on the release notes there. They're working on this a lot. It's in beta. They're doing a lot of cool improvements to it. And I've got some resources here. They actually also just released the they had some Einstein Trailhead modules, but they released one specifically for the Einstein Intent API. The main Einstein site has their documentation, which is really good. You can sign up there. You can get your certificate and your keys. You can look at some Salesforce research, things like that. And then also a GitHub repo for this session with all the code that we saw, both for the Node.js transformation script, the Heroku proxy, which we didn't look at, and the Lightning component Visualforce page is in the GitHub repo. And with that, we have a few minutes, I think 5 to 10 minutes. If you guys have some questions, we can go back, step through any of the code or any of the slides. There's a microphone here if you have any questions.
Yes, on the learning curve where
Yeah.
it started to go down again,
Yeah.
can you go back and pick the model at the high point, or does the system automatically do that?
Yeah, I'm not too sure. Actually, one of the downsides, there's pros and cons to having machine learning provided as a service. The pro is you don't have to worry about all the gory details, but the con is you don't actually know the intricate workings. In some sense, it's a black box. So I don't know, this was just released, and to figure out how some of these things work, you almost have to do trial and error, kind of reverse engineer it. And I've talked to some of the PMs and gotten a few details there, but I'm not exactly sure how it's looking at the accuracy through each epoch to determine how much further to go. It does, if you say do 1,000, it won't always do 1,000. But if you say, and it wants to cut it off at 60, if you say do 10, it will chop it off at 10. So you can kind of scale it back, but you can't scale it up.
Okay, thanks.
Does that answer your question?
Yes.
Yeah, okay. Any more questions?
So to continue with the question, does
Sure.
that mean that sometimes feeding more data into the system will actually hurt the prediction?
Yeah, I think if it's more data that's, noise of low quality, it could hurt it. In general, you need a lot of data to do machine learning, and the more data, the better. So I think it's a combination. You need quality and quantity. But yeah, potentially could hurt it if it was masking the actual correlation power of the good data. Thanks.
Hi. So you did everything using, of course, the natural language processing here, right? Mm-hmm. Did you compare this approach with if you were to do it with actual, say, numeric data on the quantities bought for each product, and using something like, say, Einstein Data Discovery? Did you compare and contrast which might be more effective?
I didn't, but my gut feeling is that this isn't the most effective way to do it, but it's an interesting way, and it's a way to learn Einstein Intent. I think, with natural language processing, you're giving up capabilities to do things like, numeric variables. And that's where prediction I/O could be a good choice to do something like this. Depends on your use case. So there's definitely potential here, but it may not be 100% the most natural fit for doing this. It's just a very cool use case. And if your use case is skewed more towards unstructured, sentences and pulling data from things, product names is okay, that's words, but these other things, I think demographics like your words about your industry, like you're a plumbing company or a surfing school or something like that, you can bring these things in. So it's not like it's not always clear cut. There's pros and cons to the different approaches. But yeah, I think for just pure accuracy, you could probably get better initial results with something like prediction IO classifiers that can take in some numeric data and things like that.
Got it. So you're not using prediction IO here?
No, this is Einstein Platform Services.
Oh, the platform service. Okay.
Yeah.
Okay. Got it.
Okay, thank you.
So you have that predict button, and that pops up the Visualforce page with the result.
Yeah.
Are you making a REST API call to Intent API on the click of that button and getting back the data and populating it here? Or is this going to Heroku? I mean, where is Heroku in picture here, or is it not?
Yeah, so it's pretty much this slide that we saw here. So we are looking at the Salesforce CPQ quote. We click the button. It's actually using the Heroku proxy. It's taking the product names and building a sentence or a paragraph and feeding it through the proxy and getting the result there. If we want to look at the code for that, we're using...
And is the Heroku proxy needed here? I mean, you could, I believe, still directly call the Intent API from here?
Heroku proxy is not required. It's more around, the main use case for it is around governor limits. So if you're trying to do, big data sets or, a big document for prediction, like let's say you have a quote with, I don't know, I haven't found the upper limit yet, but it's pretty big, but let's say you have like 10,000 lines on your quote. You try to funnel that through an Apex HTTP call out and it gives you a failure for a governor limit. Then you have to move like client side with some kind of a proxy.
Okay, cool. Makes sense. Thanks.
Yeah, thank you. All right, I think we're out of time. Thank you guys for coming. All right.